This is a video on the week 7 throwback sheet on naming compounds or nomenclature. So I'm going to talk to you here about how to name ionic and covalent compounds. The first thing is you have to determine if they're ionic or covalent. And so you have to know the parts of the periodic table, sort of. What we've got here is it's mostly metals. You can see that those are in blue, but there's on the right side there are green substances. Those are the nonmetals. And then there's those oranges, which are right in the middle. Those are called metalloids or semi-metals. Those ones are kind of metal-like, kind of non-metal-like, so they're sort of in the middle. And then notice hydrogen there off in the top corner is a non-metal as well. And so being familiar with where the metals are and where the non-metals are is sort of important to this process because it helps you identify if it's covalent or ionic. The definition here that we're going to use for ionic substances is usually it's going to be a substance that contains a metal and a nonmetal. Remember, this is where electrons are transferred from one atom to another. And then the other one is covalent substances, which are two nonmetals. So I'm going to go through and talk about now how to name them once you've determined whether they're ionic or covalent. But maybe just take a second to pause the video and make sure that you've got these ideas. Make sure you're familiar with the periodic table. On your periodic table, the black and white one, there's just a line sort of next to the metalloids, and you'll consider everything on the right side of that line to be nonmetals and everything on the left side to be metals. And remember again that hydrogen is a nonmetal. All right, so this is how we're going to go through and name things. Is a little bit of a flow chart to help you out. The first question you have to ask yourself, is it ionic or is it covalent? If it's ionic, there's two different sort of substances you'll encounter. One, you know the charge on the metal, and the other one, you don't know the charge. If you know the charge on the metal, if it's one that only has one possible charge, meaning, for instance, like zinc is always 2+, silver is always 1+, calcium is always 2+, things like that, then you can just name it. And the naming structure usually goes metal, non-metallide, like sodium chloride or potassium phosphide or something along those lines. And that's how you name it if it's a binary ionic substance. It's just got two things. Sometimes there's a polyatomic ion involved, and then you just name it with the name of the metal and then the name of the polyatomic afterwards. So something like calcium carbonate or silver nitrate or something along those lines. I should mention here that ammonium, NH4, is a positively charged ion, and it's not a metal. It's the only thing we're going to encounter here where there's a polyatomic that's positively charged. And basically, it takes the place of the metal in the substance. So if it's got NH4 on the front of it, it's actually ionic, and we're going to name it ammonium and then either non-metallide at the end or ammonium and then the polyatomic at the end. If you don't know the charge, then you're going to have to figure out which sort of metal you're talking about. And so, for instance, things like copper or iron have multiple possible charges that they can take on. And so you have to figure out which iron or which copper you're talking about, the one with the charge of +1 or the one with the charge of +2. And the way that you do that is by looking at the substances they're in, and even though the different parts of them are charged, for instance, like a chloride might have a -1 charge, altogether, you're going to assume that the substances have neutral compounds, and so they're going to be canceling out altogether. So what you do is you look at what it's attached to and determine the charge of the metal based on what it's attached to, and I'll go through some practice with that. And then you have to use either the Roman numerals or the Latin names to identify which metal you're talking about, like the 2+ ion or the 3+ ion, for instance. Now, on the other side, if we've got two nonmetals, if you determine it's covalent, then you just have to use the prefixes. So you're going to have to memorize those different prefixes again if you don't have them down. Mono, di, tri, tetra, penta, hexa, hepta, and octa. And then you just don't use the mono prefix if you're talking about the first element in the substance. You would use mono if there was only one of the second element in the substance. And then the name is always going to end in "ide." So, for instance, hydrogen phosphide or oxygen sulfide or something like that. And it all depends on what you've got there. If you're going the other way, I think going from the name to the formula is actually quite a bit easier. First, again, you need to determine if it's ionic or if it's covalent. If it's ionic, what you do is you figure out the charges of both of the substances in the ionic substance, and then you do the crisscross to figure out how many of them there are. Okay? And then remember here I said that the Roman numerals tell you the charge. So if you've got copper 2, that's Cu2+. Or if you've got Mn4, manganese 4, that's Mn4+. And so remember that Roman numeral indicates the charge. For covalent substances, you just have to read the prefixes and see what elements are in there. I think the covalents are pretty easy to go from the name to the formula. So that's that. I'm going to pull out the throwback sheet and we'll go through that now. So this is the sheet, and the first one here, KCl, you have to figure out what that is. The K is a metal, it's potassium. Cl is chlorine, it's a nonmetal, and so this is an ionic substance. You can look up K on the back of your periodic table. You'll see there it says potassium, and it doesn't have a Roman numeral after it, which indicates that there's only one kind of potassium. And so that makes it nice and easy, because if it has a metal with a known charge, you just name it metal, non-metallide, or metal plus the polyatomic. And so this one is the binary, so we're just going to name it potassium chloride. The second one here, C2O2. Carbon is a nonmetal, oxygen is also a nonmetal. So we're going to name it using the Latin prefixes. We say dicarbon because there are two carbons, and dioxide because there are two oxygens. And so for the covalent, it literally just says the formula, but with the prefixes saying how many there are. This next one here, we're going from the name to the formula. It says it's tin 2 oxide. And so remember with ionic substances, what you're doing is you look at the charges and you do a crisscross. Tin 2, the Roman numerals tell you that we're talking about tin and it has a 2+ charge, so Sn2+. All right, and then the oxide, that's O2-. When we crisscross those, we get 2 and 2, and then that actually reduces down, so we'd get 1 and 1. So SNO. Calcium carbonate. Again, this is a metal, and then the carbonate is a polyatomic, which has some nonmetals in there. So this is an ionic substance as well. The calcium is Ca2+. The carbonate is CO3 2-. And we get the same situation here where it's 2 and 2. They're already going to be neutral. If you crisscross and then we reduce down, we just get one of each. So it's CaCO3. Oxygen dichloride. This one here, oxygen is nonmetal. Chloride is coming from chlorine, which is also nonmetal. So this is a covalent substance. So because it says oxygen there, we know it just has one. And dichloride says 2 chlorine, so OCl2. This next one, NH4NO3. You need to identify what that NH4 is, and so be sort of careful about this. That's ammonium. Remember, ammonium is the only positively charged polyatomic ion, and so if you see NH4 at the beginning of a compound, it's going to be ionic. It's the only thing that's ionic that doesn't have a metal in it, and it's because NH4 itself is ionic. And so because it's ionic, we just name it ammonium and then whatever it's attached to. In this case, it's nitrate. If it was just one thing after the ammonium, you'd end it in IDE, so like ammonium chloride or ammonium phosphide or something like that. But what we're going to do here, since it's a polyatomic, is we'll just name it ammonium nitrate. And I should say, all of these are on the back of the periodic table, so you can find nitrate on there, NO3. When I had said carbonate is CO3 2-, that's on the back of your periodic table. So, you know, make sure that you kind of are used to that list and used to finding things on that list, because that's what you're going to need to do. This next one, aluminum dichromate. So aluminum is a metal, dichromate is a polyatomic ion. So aluminum, if you look it up on the back, is Al3+. The dichromate is Cr2O7, and that's got a charge of 2-. And so then you crisscross here, we get a 2 down here and a 3 down here. And what we end up with is Al2, and then we have 2 of the chromates, so we need, 3 of the chromates, so we need to have parentheses to indicate that we have 3 of the entire polyatomic ion, so Cr2O7, and then we close the parenthesis, and we have 3 chromates. This next one, phosphorus and hydrogen, those are nonmetals, both of them, so we're going to identify it as a covalent substance. In that, you just name what it is and use the prefixes. We don't use mono for the first element in the substance, so we're just going to start it off by saying phosphorus. And then there are 3 hydrogens, so it becomes tri for 3, and then hydrogen becomes hydride because covalent always ends in IDE. All right, this next one, CuF2. Copper is a metal. Fluorine is fluoride. That's a nonmetal, and so we've got an ionic substance here. If you look up copper on the back of your periodic table, you'll see that there are 2 different kinds of copper. There's Cu plus and Cu2 plus, and so we have to figure out which one we're dealing with. It's attached to 2 fluorines here, and fluorine has a charge of -1, and there are 2 fluorines, so the overall negative charge is -2, which means the positive charge has to be +2, okay, and there's only 1 copper there to take on that +2 charge, so that makes this one copper 2 fluoride, or cupric is copper 2, if you look it up on the back. Cupric fluoride. On the quiz or test, you're not going to be provided, you're not going to be asked to identify both of these. I'll just have one or the other on there, so make sure that you know how to do both ways. And you'll just have to identify what the name would be, and either one of those could be on there, so make sure that you know how that works. Al2O3. So this one here, a metal and a nonmetal, so that makes it ionic. The metal is aluminum. Aluminum has a known charge, it's +3, so we don't have to figure out what its charge is. The O is oxide. That's also on the back. So we just name this one metal, non-metallide, so aluminum, oxide. Gold permanganate. This is an ionic substance because it's got gold in it, which is a metal. Gold is Au3+, when you look it up on the back. Permanganate is MnO4-. If we crisscross, we're going to have 3 permanganates and just 1 gold. So it becomes Au, and then 3 permanganates. You got to use parentheses again. MnO4, 3. Next one, disilicon tetroxide. So this one, the prefixes here should alert you maybe to the fact that you're talking about a covalent substance. Also, we've got silicon here, and we've got oxygen, both of those nonmetals. So disilicon says there's 2 silicons, so Si2, and then tetroxide. Tetra is 4, so that's saying 4 oxygens. MnO2. Mn is manganese. That's a metal, so there's going to be an ionic substance. If you look up manganese on the back of your periodic table, you'll see there are multiple possible manganeses. There's manganese 2 and manganese 4. We have to figure out which one we're talking about. O2 here, we're going to assume it's oxide. You could also, there's peroxide listed there, but I'm not going to use peroxide unless I specify that specifically this is peroxide that we're dealing with. So we're going to assume that we've got 2 oxides here. Each oxide has a charge of 2-, and so the overall negative charge, if you've got 2 oxides, is -4. And if we've got an overall charge of -4, then this manganese has to have a +4 charge. If that one's got a +4 charge, it makes it manganese 4. And then the end of it is oxide, because those are oxides on the end. The other possibility here, if you want to use the Latin name, this is the larger charge, so it's manganic oxide. Strontium iodide. So find strontium. It's got a charge of 2+, so it's SR2+. Iodide is I-. Both of those on the back of your periodic table. Crisscross, we have 2 iodides, 1 strontium, so it's SRI2. And then for silver nitrate, again, this is ionic because it's got silver. Silver is Ag2+. Oh, that's just Ag+, sorry. So we've got Ag+. And then the nitrate, that's on the back as well, NO3-. Okay, since it's 1 and 1, when we crisscross, nothing happens, so this one just becomes AgNO3. All right, I know this one is especially complicated, so you might want to go through and really try and practice it all the way through, or do more examples from the internet or something along those lines. Feel free to come in and ask me if you have any more questions about it. But this is sort of a quick summary of how you do these problems. So yeah, I hope that helps.